The last thing I would like to talk about is how to create your own module. So here I have a file, moduleYourOwn.py, that I've opened on the left. And I have a bunch of other folders. So one is called a folder, and another one another folder. And these contain subfolder and some modules. And I will open these in a second. And you can see that there are some __init files and some other subfolders as well. A trigonometry subfolder, etc. So what's happening? So let's first run this thing. So if I run module your own, you will see that all kind of things are happening, and we will see the explanation here on the left when we actually run it. So first, I'll define a prompt because it will be easier to tell what is going on. So we'll try first to import another folder. And you can see that importing another folder, which is here, when we try to do it, produces an error because then the prompt is printed, but all kind of error messages are printed. So there is no module named another folder, and it's actually not quite accurate or not precise enough. The folder another folder exists, but does not have a py file in it. So if I look at another folder, you see here that there is no _init .py file. Okay, so this is unlike everything. So this is the bad guy, if you want, the one that is not done well. Another folder is not done well. A folder is done better because a folder has an init.py file. It also has an init.pyc file, but this is because I just executed the program. It was just created. So if I remove this init.pyc file and rerun my program, you'll see that this pyc file is recreated. And same thing in the subfolders. So this is the right way to create a module, is by putting a package, so putting modules together. It's to add an init.py file. And you can see that there is also one here and also one there. So this means that when I import a folder.a_subfolder.a module, I'm basically over here importing the content of this file. And this is just a module, and it was just created to show how modules can be organized, etc. And it contains just one function. So let's see what happened when we executed this. Well, we imported a folder.a_subfolder.a module, and this basically executed one after the other all the Python init.py files, and we see that we are now inside the init.py of a folder is printed. So this is here. This is the result. And then it went and executed the init.py of a subfolder, which was empty, so nothing was done. And then finally, we imported a function. And then we decide to run a function, and a function just returns a string. This function, a function, returns this string. So we see here that when we execute this function, we print this guy with the prompt, right? We also asked the prompt. So now we can also use different types of imports, named imports or relative imports. So we can start doing from a folder.trigonometry import trig functions. So if you want, I have a folder, and within that I have another folder called trigonometry, and this folder contains an init.py file, so it's really a module. So it's really a package. So within this package there are different modules, different py files if you want, and I've decided to import specifically the trig functions.py file. So this means now that if you want, in my program, trig functions is known, and I can use trig functions dot anything that is defined within trig functions. So let's see what is defined there, and that will be okay. So what is defined there? Well, two functions, my sinus and my cosinus, and so I can call trig functions dot my sinus, and this is what I have here. When I compute trig functions dot my sinus, I get here the output. But I can also import directly, of course. So I can do from a folder trigonometry trig functions. I can import my cosinus, and then I can just use my cosinus 1.56. So notice the difference here. I use trig functions, and here I didn't. Okay, so after all this, it's kind of nice to look at really what happened and print the current directory, so all the things that are known. And so what's known to the program at this stage? Well, the built-ins, the doc, the file, the name, package, warning registry. So all those things exist by default. Actually, warning registry is added because of the import error above, but that's okay. But more importantly, a folder is now defined. E is now defined because this was catching the exception here. We'll see this later in the course. My cosinus is defined, or is bound to something. Prompt is bound to something, and trig functions is bound to something as well. Okay, so my sinus was never exposed directly. It's only my trig functions that is known. So that's why my sinus does not appear here. So just to summarize, if you have a Python module, meaning a .py file, that's fine. But if you want to put a lot of them together, you have to make a package, and this package can be put together by creating a folder where you put all your module files, and by adding a __init__.py file, which can be empty. It can have some code to execute, or can also specify or bind the all variable, and this would just specifically say what to import when you import that package. And this basically ties together all the different modules in that folder into one coherent package that you can actually import. So all the different Python modules that you have seen so far, OS, sys, etc., those are all really packages, and when you import, you're accessing this big folder with lots of different files, and the all variable is defined so that all kinds of stuff gets added to that module name dot, and so that you can access it in that way. Okay, so this was for the method to create your own Python package.